Hello, Honors Calculus class. Welcome to the second video of Chapter 2 to get you ready for the Chapter 2 test. So if you want more information about what I'm about to talk about, please go to pages 147 to 151. So I'm going to start by reviewing the leading coefficient test. So this helps you to decide the end behavior of the graph, and it can help you sketch a graph a little quicker. So when we're dealing with even degree, so this would be your x squareds, your x to the fourths, your x to the sixth, and so on. If the leading coefficient is positive, it's going to open up like a parabola. The leading coefficient is usually represented with an A. If the leading coefficient is negative, it's going to open down, like a parabola would open down. So those are your general shapes. Now moving on to odd degree, so this is going to be linears, it's going to be cubics, it's going to be quintics, and anything beyond that that has a odd power. It's going to rise when the leading coefficient is positive. Think of a line with a positive slope. It rises. It's going to fall when the leading coefficient is negative, like a line would fall if it had a negative slope. So here's a problem where we're going to sketch one full graph using the leading coefficient test and by identifying intercepts. So when I first look at this, I see that it's odd. It's odd because it's to the fifth degree. So I know that if it's positive leading coefficient, which it is 1, that it's going to rise. So it's going to look something like this. You know, the middle is what I have to figure out, but it's going to rise. I know that it's going to start from negative infinity and end going to infinity. So I'm going to get the zeros, or the x-intercepts, by setting it to 0. And first I'm going to factor out a t. So then I have t to the fourth minus 6t squared plus 9. So that was the GCF that I just took out. So I noticed that the inside is in quadratic form. So I'm going to factor it just like I would a quadratic, except I'm going to put t squared in the first two spots. That gets me the t to the fourth. And then I'm going to find two numbers that add to 9 and, multiply to 9 and add to negative 6. So that's negative 3 and negative 3. So I'm definitely going to get some repeated zeros here because they're the same. So one of the zeros is at 0. So that's right here. So I'll plot that. And then these two are the square root, positive square root, and negative square root of 3. So that is approximately 1.7. So I'm going to get one about here and one about there. So since these were doubles, I know that the graph is going to bounce there. So as I connect these dots, I'm going to start from negative infinity. I'm going to bounce off here, come back up, go through, and bounce off there, and end up like that. It's a pretty neat looking graph. You know, if you don't believe me, go to Wolfram Alpha or the Desmos.com with the calculator I have on my website and just double check it. Good luck!